For Dr. Brin's classes that are scheduled for 75 minutes, the actual duration of lecture is normally distributed with a mean of 74 minutes and a standard deviation of 2 minutes. A random selection of 5 of Dr. Brin's classes that are scheduled for 75 minutes are timed. Let x equal the duration of a single 75-minute class of Dr. Brin. X fits what distribution? X is the duration of a single 75-minute class, and it says here the actual duration of lecture is normally distributed with a mean of 74 and a standard deviation of 2 minutes. So X is normally distributed with a mean of 74 and a standard deviation of 2 minutes. X bar equals, that is, the distribution of the averages is what? It's the same thing as X, only we have to throw the average in there and the fact that we have a sample size of 5. So X is the average duration. The average duration of a sample of 5. Of Dr. Brin's 75-minute classes. Now, according to the central limit theorem, the distribution of the averages fits a normal distribution with the same mean as the underlying distribution and a standard deviation that's equal to the standard deviation of the underlying distribution divided by the square root of the sample size, 5. Number 4, approximate the probability that one of Dr. Brin's classes that is scheduled for 75 minutes will run over, actually run longer than 75 minutes. Well, we'll have to ask a computer to calculate the number for us, but what we're looking for is the probability that one of Dr. Brin's classes, that is X, is greater than 75. So that's going to be 1 minus normal, because X is normally distributed, mean 74, standard deviation 2, and X is 75. So we go to GeoGebra and ask for that number. One minus normal, mean of 74, standard deviation 2, variable value 75. And we get 0.30854. 0.30854. Point 30854. Number 5, approximate the probability that the average of the 5 selected lectures will exceed 5 minutes. Well, now we're being asked about the average of 5, so we're being asked to look at the distribution of the averages. So we want the probability that the average is greater than 75 now. So we need to consult GeoGebra, but this time the standard deviation is not 2 anymore. It's 2 divided by the square root of 5. but x is still 75. And again, we have to consult GeoGebra to find out what that number is. So we have 1 minus normal mean of 74, standard deviation 2 divided by the square root of 5, and the variable value is 75.13178. 0.1317.